Hello everyone, in this video we'll be discussing interfacing and decoding MPU 6050 communication protocol. Here is the learning outcome. By the end of this session, students will be able to interface MPU 6050 accelerometer cum gyroscope sensor with an Arduino microcontroller board and decode the communication protocol using Cell A logic analyzer. Here is the interfacing diagram. There might be slight change in the actual pins that we may use in our practical setup that we'll be having a look at in a short moment. Okay, so as you can see, we have interfaced an Arduino board with an MPU 6050 sensor through an I2C protocol. So the benefit of using an I2C protocol is that you can interface as many sensors as possible with a given microcontroller. For instance, if I want to interface an LCD display along with this, and I want to also interface graphics display, I want to use some a couple of more sensors which rely on the same I2C protocol, maybe like an RFID communication gadget or maybe a biometric sensor or something. And under these circumstances where you have to interface multiple sensors but the number of pins available on a given controller are less, then I2C protocol comes into picture. So how does it actually identify that a given sensor can be interfaced, or a given number of sensors can be actually interfaced with the same microcontroller on the same pin? So the benefit here that we're having is I2C protocol supports addressing. That is the way how we have specific addresses given to the houses in a given a locality, like your house and your neighbor's house have a different address, but all stick to the same protocol of the address format. Like you have maybe some A, B, C or the plot number, and then you have the numbers. So something like that. Here also we have some address that is usually fed in the program through hexadecimal numbering system. And in this case, I have attached these 4 pins, that is VCC ground, SCL and SDA, where SDL and SCA, the third and the fourth pin, actually correspond to the I2C pin terminologies. So which I'm directly connecting to the logic analyzer. So rather than spoofing the data this time, since it creates some voltage drop while I connect it to the logic analyzer, what I did is I first connected the Arduino microcontroller with this MPU 6050, and it was able to successfully get the readings out without any errors. So currently it is printing all the 6 degree of freedom readings, that is X, Y, Z, yaw, pitch and roll, the angular and the linear velocity and accelerations and all these whatever sensor readings that this MPU 6050 is able to exit out. Along with the temperature, we are able to sense it. And in the code, we have commented out the temperature code. So let's have a quick look at this code first. Under void setup, we have initialized the serial port with 115200 baud, and then we have given it a little bit of time, a 10 milliseconds time to settle down, and then we have printed a small message to the output so that we understand that the program has started to execute. And then similarly we started the sensor necessities. I mean, whenever we call this begin function, which is already defined in these header files, it takes care of all the rest of the things like calibration, setting the default configurations, all the things. So for this specific demo, we are not interested in writing our own code, but we are using a third-party library that is given by Adafruit. So for the first time, if you are trying to install an Arduino IDE and you are directly watching this video and trying to interface an MPU 6050 sensor, then you need to first of all open your Arduino IDE and go to tools and click on manage libraries. So whenever you do this, as we have even earlier discussed in our videos, it first goes and fetches all the third-party library repositories and uh, maintains a list of all the available libraries, so that whenever you search for a specific library like MPU 6050, which is the sensor which we are trying to interface now. If you search for it, then as you can see, it is going to present you with a couple of options like currently we are using the Adafruit MPU 6050 library. I have already clicked on it and installed it. You are able to see the status here with a blue colored font which is showing as installed. Once you do this, you are supposed to close this window as well as close the entire ID, the entire application which you refer as Arduino ID, and reopen it, otherwise those libraries won't be reflected. Once that is done, we have to click on the file and browse through the examples. Somewhere here you will find the library that you have installed under examples, that is Adafruit MPU 6050. Currently the program that I'm trying to use is MPU 6050 underscore unified sensors. This is the program that I'm currently using. So let me connect this controller without connecting the sensor and try to program it. Since I already programmed it, let me do it once again and check if there are any errors. Usually whenever you're interfacing any sort of sensor with a microcontroller, it is important to note, like if there are any sort of errors, those errors usually appear either because of some loose connections due to the jumper cables, or maybe you have not followed the pinout diagram of something like this inappropriately, because of which you may get those kind of errors. As you can see here, we have successfully uploaded. The status is showing that it has successfully uploaded the code. But anyways, this controller is going to communicate with the MPU 6050. So if I connect it here, it would be able to read something on the output, but for some reason it was failing. But later I discovered that the reason was completely just because of the way how we are trying to drop the voltage by connecting it parallelly with the logic analyzer. So what I decided is to not connect this MPU 6050, since without this logic analyzer that works perfectly. But currently, as of now, our core intention is to decode the protocol after interfacing. So this is as far as the interfacing part is concerned, and now we're about to decode it. So let's just grab the data. Now what I did is I have considered, I have only connected the ground of my logic analyzer to the Arduino ground, and along with that I have tried to connect channel number 0 of this logic analyzer to pin A5 of my Arduino board. So this is going to probably grab the waveforms. Like, let me connect the logic analyzer first. Okay, it is auto detected those 8 channel logic analyzer. Now this, I can close the camera. Now just pay attention on the right side. Currently channel 0 is not configured. Click on the channel and then click on analyzers. This time we have used I2C protocol, so I'm going to click on that. To which channel we are going to associate it, I'm going to map it to channel 0, and ACL is going to be channel 1. So there are 2 pins, therefore I'm going to use another cable to connect it to the immediate other pin. So the last 2 pins of I use the last 2 pins. The last 2 pins of this Arduino board, or A4 and A5, actually correspond to the I2C pins. So I have connected those 2 pins to channel 0 and 1 on our logic analyzer, and I'm trying to map the same thing under the application using this window. So let SDA be 0 and SCL be 1. Click on save. Now the analyzer is attached. We are going to simply click on start. So as soon as I click on start, anyways our controller is directly connected to the logic analyzer. So this controller is going to think like it is actually attached to this sensor, but in fact it is connected to the logic analyzer. So maybe we're not going to get any response back from the MPU 6050, but whatever initial communication this controller tries to communicate, which we usually consider as a handshaking signals or a initial communication, that would be captured under this. So let me click on I understand and click on reset button once, so that everything is set up properly. Okay, I think there should be something. Yes, as you can see here, we have a whole bunch of data which was compressed. So this is exactly how the I2C protocol can be decoded, where we have a ones and zeros, similar to the DHT11. If you recall, you can pause the video and go back and recall how we identified the information of zeros and ones for a given one wire protocol while we were interfacing Arduino with the DHT11. So you can consider this as an assignment, like you can try to decode the signals, like whether it is 0 1 or 1 0 or the lows and highs. But as of now you can easily identify, like whatever we did capture here, and this is a nice quasi protocol. Here are the references used for this video. Thank you.